Alright, so we have more questions on integration by substitution, but this time around, let's look at questions that have trigonometry, right? So now let's look at this one. So we have the integral of sine qx cos to the power of 4x dx, right? Now there's no need to put bracket. You can put bracket if you want, but there's no need because there's no like a addition or subtraction sign. If there was an addition or subtraction sign, they will put bracket, right? So we have something like this, right? And now we are to use integration by substitution, right? So now we have, but for this one now, the difference between this one and the first one that we did was that the first one was just like inside a bracket, right? That one was in the form of chain rule, right? But this one now is in the form of product rule, right? Where we have something multiplying something. So when we have something like this, you are just going to pick one. It is one of them that you will pick, that you will now say, okay, this one is equal to the substitutes, right? Whichever alphabet we'll be using, either U or V or whatever you want to use, right? So it's just what you pick that will be. So you just pick one, right? So now, how do you know which one to pick, right? Most times you might not know. You might have to do trial and error. You pick one and then you get it wrong, then you now try the second one. Not that you will get it wrong, but you meet a roadblock and you'll not be able to proceed further, and you have to go with the second one, right? But now, let me make it easy for you, right, to make a decision. Whenever you are met with something like this, right, you have 3 and 4. The one you should pick is the one that has an even number, right? Even numbers are 2, 4, 6, 8, and 10. Even numbers are this, right? Like that, 2. So out of these two now, which one has even number? Is cos. No, cos has an even number. So that's what we are going to pick. I'll explain why we are picking it as we go on. So let's say we're going to say let cos x, we're not going to pick it with the power, just cos x. Let cos x equal to u, right? This is the first step, right? Substituting. We have already picked what we're going to use to substitute. So now the next one is what? To find the derivative of this, right? So we're going to say du dx is equal to what? Minus sine x, right? You can now watch the video on trig function so you can get more about this trig function. Just check the channel, or I would try and put the link in the description. So now equals to minus sine x. That's not a to, it is sine, sorry. Minus sine x, right? So now we have this. So what's left to do to make dx solve of the relation? So we have dx multiplied by minus sine x is equal to du, then divide both sides by minus sine x, then dx goes to du over minus sine x. Alright, so now let's put it back into the integral. So we have integral of sine raised to the power of 3x cos raised to the power of 4x multiplied by du over minus sine x. Right? So we have sine x here, we have sine x. Sine x here, we cancel this sine x here. We'll be left with sine square x. Right? So we have the integral of this minus now, minus sine square x cos raised to the power of 4x du. But we're not done. Alright? Because this one now, they are still having x. We have to make it to a form that has u. Remember that cos x goes to u. So we're going to bring cos x as u here. So we're going to be having the integral of minus sine square x. Then our cos raised to the power of 4x is going to be u raised to the power of 4. Right? Because u raised to the power of 4 is the same thing as cos raised to the power of 4x. Right? That's what it means basically. So we have this, then we have du. But this sign still has x. So are we going to take it as a constant? No. We have to also change it to a form that has u. How do we do that? Now, from your trig identities, we know that sine square x plus cos square x is equal to 1, right? But now we know that cos x is equal to u. So let's make cos x the solid of the formula. So we have cos. So we can say that sine x, right, sine square x is equal to 1 minus cos square x. So this place where we have sine x here, sine square x, now we can put this as our value. So we have the integral of 1 minus cos square x multiplied by u raised to the power 4 du. But it still has x, right? We will take care of that now because we know that cos x goes to u. So we're going to be putting u here. So we have the integral of 1 minus u square, everything multiplied by u raised to the power 4 du. So now let's simplify this. So now we have u raised to the power 4 times 1 is u raised to the power 4. Then minus u raised to the power 4 times u squared is u raised to the power of what? 6. Everything in bracket. Then we have our du. So now this one now looks like a very, very normal linear equation that we can just find the integral, right? So we're done with step 1 to 4. So now let's first find the integral. Let's find the integral now. So we're looking for the integral of u raised to the power of 4 minus u raised to the power of 6 du. You can pause the video at this point to just continue it to check if you still remember what we did when we did definite and indefinite integrals. Alright, so for this one now, you're going to be having u raised to the power of 4 plus 1 over 4 plus 1 minus u raised to the power of 6 plus 1 over 6 plus 1. Right? Then plus c, because this one is indefinite integral. So we have u to the power of 5 over 5 minus u to the power of 7 over 7 plus c. But our u is what? Our u is cos x, so we have to put it back. So this is going to be cos raised to the power of 5x over 5 minus cos raised to the power of 7x over 7 plus c. So this is our final answer. Yes, I know that we're having u raised to the power of 5, but u raised to the power of 5, because we have cos x equals to u raised to the power of 5 is not going to be cos x raised to the power of 5. No. When you do it like this, then that means only the x has the 5. But this thing means that cos x raised to the power, this is what it means, right? This one is equal to this. This is what it means. This is how we write it in mathematics. Don't make the mistake and do it like this. This is wrong. This is correct. So you do it like this, right? Because I know you must have been confused, but this is how we do it, right? So this is our final answer. Very, very simple stuff. You follow the 5-step approach, then you will be good to go. So now let me just drop something very similar to this. So that we can try. Let's see what we have learned. Let's see if we can apply it. All right. Okay. So now look at this question now. Find the integral of sine square x cos raised to the power of 5x dx. Alright, at this point, I implore you to pause the video and try this out on your own. Alright, very good. So now let's solve this together. So now, what I said is either you do it by trial and error. You can just pick one and then you try. If it does not work, then you try the second one. But imagine you're doing CBT, you have limited time. You're doing exam, you have limited time. So how do you go over that? Remember I said the one that has an even number is what you pick. You pick the one that has even number. If two of them have even number, then you go and start praying to God, because I don't know what you do at that point, right? But if two of them have even number, then you do trial and error. But most likely you will not be given the one that has even, that the both of them are even numbers or the both of them are odd numbers, right? So you are faced with something like this. Pick the one that has an even number and let's go. So the one that has even number here is sine, right? So we're going to say let sine x is equal to u. So now find the derivative. So du dx is equal to what? Cos x. Then we'll make the x subject of the formula. That's going to be du over cos x. So we have this now. So let's put it back. Remember, sine x equals to u, so that means this sine square x will be equal to what? U squared, right? So we have u squared cos raised to the power of 5x multiplied by du over cos x. This will cancel this, so we have cos raised to the power of 4x, right? So we have the integral of u squared cos raised to the power of 4x du. Now this cos raised to the power of 4x has x in it, so we have to change it, right? Still using your trig identities, where you have sine square x plus cos square x is equal to 1. We can say that cos square x is equal to 1 minus sine square x, right? So this means that cos square x, because now sine square x is equal to what? U, right? It's equal to u square, so we have u square. So this is it. So we can bring this, but now this one is having cos raised to the power of 4x, right? What you just need to know is that cos square x multiplied by cos square x is equal to cos raised to the power of 4a. According to your laws of indices, you can see that this is u square plus u times u square will give u raised to the power of 4. So that's just how it goes, sha. So we have cos raised to the power of 4. This times this. So now, because cos square x goes to 1 minus u square, remember what we want to have is that everything here is u, so that we can just integrate, right? So here we can just put 1 minus u square multiplied by 1 minus u square then this is going to give us 1 minus 2u square plus u to the power of 4. So let's put this as our value for cos x. So we have the integral of u square multiplied by 1 minus 2u square plus u to the power of 4. Then we have our du. So this integral now is going to be u square minus 2u to the power of 4 plus u to the power of 6 du, right? So now we have a linear equation that we can just go ahead and then we solve. So let me just clean this so we have space. You can pause the video at any time if you want to, right? Alright, so let's have this. So we have the integral of u square minus 2u to the power of 4 plus u to the power of 6 du. So we have this. So now we're going to be having the integral of u squared du minus the integral of let's bring these two out because they're constant, u raised to the power 4 du plus the integral of u raised to the power 6 du. So this is going to be u raised to the power of 3, which is 2 plus 1. Let me just write the steps. 2 plus 1, in case anybody has forgotten, minus 2 into the bracket of u raised to the power 4 plus 1 over 4 plus 1 plus u raised to the power 6 plus 1 over 6 plus 1 plus c. Don't forget your plus c. So this is u raised to the power 3 over 3 minus 2 u raised to the power 5 over 5 plus u raised to the power 7 over 7 plus c. Remember, our u is what? Sine x. So this is going to be sine cube x over 3 minus 2 sine raised to the power 5x over 5 plus sine 7x over 7 plus c. So this is our final answer for that question. So let's take 2 more questions. Let's take a few more questions. Alright, so let's do this. Okay, so this is the last question I'll be looking at in this video. So we have x squared e to the power of x cubed, right? Many of you saw this in the flyer. So let's look at how to go about this here. So we have x squared and then we have x cubed, right? So now for this one what we're going to do here, because this one now we're not dealing with trigonometry, right? We're not dealing with trigonometry. So for this one, what we're going to do here is that this one that has a higher power, x to the power of 3, is what we're going to take, right? We're going to take x to the power of 3, which is odd. So we're going to say let u is equal to x to the power of 3. Now, because u is equal to x to the power of 3, we'll find the derivative du dx, and that's going to give us what? 3x squared. Then we got 3x squared. So now make the x out of the formula. So du over 3x squared. So we impute it now. So we have x squared e raised to the power of u, because u is equal to what? X cubed. Then we'll have multiplied by du over 3x squared. Right? So you can see why we needed to use the one at the top, because when we differentiate it, we're going to get something that we'll get it in a form that has x squared, so we can cancel out that x at the back, right? So this x squared will cancel out this one. So we are going to be having the integral of this is over 1 over 3, which is a constant. So we have 1 over 3. We have e raised to power u du. Then we'll just integrate this. So then we are going to have 1 over 3 into the bracket of e raised to power u plus c. So this is going to be e raised to power u over 3 plus c. So this is what we have, and this is our final answer. Because this u is equal to x raised to power 3, so we have x cubed over 3 plus c. So this is our final answer, and this is basically what integration by substitution is all about. It is very, very simple. You can try these ones out. Send it to my DM, and let's check your. Send it with the solution, please. Don't just send your answer. Send it with the solution so that I can check it. And once I check it, I know that okay. So in case you make any mistake, I can easily point out your mistakes. This is the x and this is the x. So try these 2 questions and send it to my WhatsApp number 081 5690 993 5. Send it with your solution.